Research discovered signs of life on Saturn 2022. The icy crust enveloping Saturn's moon Enceladus has long fascinated astronomers. Evidence collected by NASA and the European Space Agency's Cassini-Huygens spacecraft suggests the shell could be hiding a massive subsurface ocean made up of briny water underneath it, which, tantalizingly, could potentially harbor life. According to a new study by a team from the University of Arizona and Paris Sciences and Lettres University, published in the journal Nature Astronomy last month, Cassini's observations that found Enceladus is expelling plumes of methane gas suggest that the moon's subsurface oceans may be habitable to Earth-like microorganisms. We wanted to know, could Earth-like microbes that eat the dihydrogen and produce methane explain the surprisingly large amount of methane detected by Cassini? Asked Regis Ferriere, an associate professor at the University of Arizona and a lead author of the study, in a statement. But figuring out the answer for sure is far from easy. Searching for such microbes, known as methanogens, at Enceladus seafloor would require extremely challenging deep-dive missions that are not in sight for several decades, he added. The team constructed mathematical models to see if methanogenesis could account for the data collected by Cassini. Their conclusion: microbial hydrothermal vent activity, or processes that would involve extraterrestrial microorganisms, could explain the methane detected by Cassini. On Earth, hydrothermal activity is caused by cold seawater dipping into the ocean floor, where it gets warmed up by local sources of heat like magma. This water then gets expelled out of vents in the ocean floor, a process that drips methane into the water over time. Most of this methane is released by microorganisms that use the heat as a source of energy, turning carbon dioxide into methane. According to their computer simulations, the researchers found that similar conditions could exist on Enceladus. In summary, not only could we evaluate whether Cassini's observations are compatible with an environment habitable for life, but we could also make quantitative predictions about observations to be expected should methanogenesis actually occur at Enceladus seafloor, Ferriere said in the statement. In fact, without the existence of biological sources of methane production, the levels of methane observed by Cassini couldn't be matched using their models. Still, it would be premature to draw any definite conclusions. Obviously, we are not concluding that life exists in Enceladus ocean, Ferriere added. Rather, we wanted to understand how likely it would be that Enceladus hydrothermal vents could be habitable to Earth-like microorganisms. Very likely, the Cassini data tell us, according to our models. We simply don't have enough data to go off of just yet. In other words, we can't discard the life hypothesis as highly improbable, Ferriere said. To reject the life hypothesis, we need more data from future missions. The researchers also didn't rule out other possible abiotic processes that could explain the methane data. For instance, the chemical breakdown of primordial organic matter in the moon's core could be causing significant amounts of methane to be ejected. It's exciting new research that goes to show how little we know about Saturn's icy moons, despite Cassini's extensive legacy. Perhaps one day, another mission will even get a first-hand look. Attention is now shifting onto one of Saturn's moons, Enceladus. It has an ocean under an ice crust, and at its bottom, hydrothermal vents produce plumes of material rising up through cracks in the ice and into space. In 2015, the Cassini space mission sampled these plumes, revealing substantial amounts of hydrogen and methane. So much of it that Regis Ferriere at the University of Arizona, US, and colleagues suggest it could be living organisms producing it. Having conducted computational modeling experiments, they argue that abiotic chemical processes cannot fully explain the amounts of methane measured. However, Lettres, who has researched Enceladus for a long time, doesn't think the study provides many answers. Methane by itself isn't a biosignature, he explains. We see methane in comets. We see it in interstellar medium, we see it on Titan. He suggests that other measurements, such as carbon isotope analysis, would be required to determine whether the methane could be the result of biotic processes. According to Ferriere, scientists worldwide have been pitching missions to retrieve more data from Enceladus, but none have been funded so far. Thank you for watching.